Hi everyone, so I'm David Myall, and this is the first of a series of talks I'm going to give about the piping life cycle. And today's talk is about design, not specifically, I'm not going to describe to you the whole process of engineering design. First of all, this is about piping, and secondly, the focus is on preparing piping information for transfer to downstream work processes, such as fabrication. Now, when we start piping design, we need a number of things. We're going to build a 3D model, we need a piping and instrumentation diagram, and we need some reference data that contains piping specs and other piping material. And as you know, we can go through a number of stages, perhaps where we're defining the concept that we're designing. We might do a feed, a preliminary design study, which is more detailed. And eventually we get to the point where we want to have sufficient detail in the 3D model to drive the fabrication processes, because we need to turn this 3D model into a physical plan. And this is the process that in the world of piping comes down to the creation and management of piping isometric drawings. And this is kind of quite an interesting and very familiar to everybody, but kind of quite an interesting work process. And the important thing is to understand how the management of these piping isometrics affects what happens downstream. We want to look at this whole process from beginning to end in terms of optimization, not just optimizing design, but optimizing the whole process. So why do we need piping isometrics when we've got this perfectly nice 3D model? Well, the 3D model gives us a lot of detail. It gives us a complete material takeoff, and it makes sure that everything is going to fit because we're doing clash detection and we're making sure that all the piping and the structure and the equipment is going to fit together. But I can't give that 3D model to a piping fabricator. He may not have the skills to use it, and what he's used to working with is drawings. In the case of piping, that's typically a piping isometric drawing, which is a schematic which fully details all the dimensions and the material in the pipe. So if I've got that drawing, I've got enough information to actually make that section or that piece of the overall piping. And I can be sure that if I follow those instructions when I go to site and erect it, it's all going to work and it's all going to fit. So the piping isometric sort of represents a unit of work. Now, there's one issue with the isometric which is quite important, and this is the question of sheets and the content of each sheet in the piping isometric. So if what we're trying to do is transfer information about a particular pipe to fabrication, it could be that that pipe is too big to fit onto one sheet of paper. So the piping isometric ends up being split into multiple sheets. And this is kind of an artificial concept. This has nothing to do with the reality. It's just the way the drawing hangs together. And there's actually typically two different ways in which this is handled. One is that the isometric is automatically generated as a single document with multiple sheets. And the other way of doing it is to manage the data in the 3D model so that each piping isometric contains just enough information. So you're actually splitting up the model based on the amount of data you can get in your piping isometric drawing. And again, this is a rather artificial construct because we are dividing up this model for our convenience of drawing production, which is kind of backwards. Because when we come down to passing this data off to fabrication, they're actually going to be driven by the contents of those sheets, which isn't necessarily done for their benefit, but for the benefit of the engineering company who is producing this documentation. The other thing to consider in terms of piping design is the information that you are passing on. We've talked up to now about these as being drawings, which they are. I mean, the piping isometric is very familiar to everybody. It's a very convenient way of passing information. But what we fundamentally want to do is pass some data rather than documents downstream to the piping fabricator. And if we're passing data, think about the quality and quantity of data. There's certain information that is a key driver in the fabrication work processes. These are information about the material that the pipe is made of, the weight of the components, the piping schedule and the rating. That if we are taking the trouble to pass information, we need to make sure that this information is included, because otherwise the piping fabricator is going to have to replicate it. So although you don't need it in terms of producing these documents, it's very important in terms of optimizing the overall workflow that that information is included as data when it is sent downstream to the piping fabricator. So that completes our the first part. We've done our engineering design, we've delivered information down to fabrication. In the next coffee break, we'll have a look at what happens to that information as we move into the work preparation stage.